Well, hi. Today we're going to look at the Ameritron ALS-500M. I'm sitting here over on EM and I'm reading all these reviews, and this one guy sits here and he talks about how he had one, broke it in a month, had another one, broke it in another month, had another one, broke it in 2 weeks. You can't have that many failures without having to ask yourself if there's something wrong with your system. Now, I've heard ups and downs on this little box, and this is the first one of these I've ever had here, so we're going to rip it apart and take a look at the inside, and we're going to talk about it and all kinds of stuff. Let's scroll down to this one here. Nightmare MFJ amp with cold solder. He goes on and on and on and so-called Ameritron from her in Germany says they would like to send me a free new set of transistors if I pay the FedEx. So they were PP100 Chinese clones of the Toshiba 2879 Japan. Japan no longer makes them. I said sayonara and just paid $260 for rfparts.com to FedEx me fortune. Okay, so right there we know that this is a really, really old post. That's from back in 2018. RF Parts. That was back when transistors are cheap. The transistors that are in here are now 250-ish dollars a piece. Then he goes on to never buy an amp anymore unless it's got the next generation LDMOS transistors that are a BLF188XR Amphion. NXP is as fine as the Amplifier is their newer name. That's not correct. NXP and Amplifier are two separate corporations. They might be owned by the same master, but I doubt it. These old 2879s are a 40-year-old technology and cannot handle any bad SWR. That's right, because you're supposed to use an antenna tuner. At least that's what they taught me in my ham manual when I read it when I was a kid, when I was 12. The third generation BLF 188XR technology can handle 95 to 1 SWR. And they will never blow on you. No, but you can overdrive them and they'll explode. Do not buy any Ameritron, LDMOS. Okay, so here's the deal, yo. This amp is still currently in production, but the transistors that are in this are not like the transistors in the part that you buy today. The component that you buy today, you're going to pay $1,100 for an all-band, all-mode amp that are made with, well, not going to lie, Chinese equivalent-ish replacement of the Toshiba. It's still not the same. I was thumbing through and just looking at stuff. We're gonna redo all this mess here. This right here. No, bad. This is no good. And do you think he was thinking that he might have some interference issues going on? This plug with their little piece of 12-gauge zip line that they attached to it, I was absolutely in shock. They want $104 for this plug. The power wire that's on here is actually better than what comes from the factory. Blows my mind. Okay. I went out and I purchased us a brand new remote head unit for this thing. It's like 84 and some dollars pre-shipping. It's about 104, 105 post-shipping. Because I wanted to show the remote functions of this thing, and I wanted to actually, you know, do this thing due diligence, right? Because I mean, I don't know about you. I'm not a vibrator replacement specialist. I am just a very highly motivated amateur operator like the rest of y'all, right? Wink, wink, nod, nod. And yeah, vibrator replacement specialist is a guy trying to make a lesbian go straight. So, I sit here and I keep reading these, and it's like a lot of really, really good reviews and 1 or 2 fairly bad ones, and I think that comes down to operator error. There's one dude that actually writes in here that he blew it up because it was his fault. I mean, I respect his review more than I do respect the two out of like 50 that were dogging this thing. So I've heard mixed reviews on this thing, and I want to see what it's like on the inside and what it does, period. And I took this in on the blind. I have no idea if this works or not, but I guarantee it's going to work by the time it leaves. Yeah. So let's get into the crux of it, and let's start looking at things. It's a 100-watt drive max on this thing. I would strongly suggest that you don't do that to this piece of equipment. You operate it at slightly reduced power. Of course, let's flip it around. Let's take a look at the back here. This is the grounding lug, of course, RF in, RF out. This is your manual relay operation, even though it's got a remote. I'll show you that here in a minute. And then this is your $100+ proprietary plug that's on the back. Another thing I want to talk about is when you are looking at these, you have to keep a good eye on the serial number. If the serial number on the back of the amplifier is higher than 13,050, you can buy the very cheap $104 remote after shipping control unit. The ones that are below that are $350 to $400 depending on what serial number is on the unit. So just keep that in mind. While on camera this cabinet looks like it's hash, but it's absolutely not. It's absolutely not. It's got a little scratch on it that's not even... Anyhow. Interior cabinet, good shape. No rust, no corrosion, no nothing. Okay. The reason I point all this out is because eventually we want to sell this. We're not interested in keeping this. This is like got for YouTube video alone. Just so I could shoot the YouTube videos. So that means it needs to go onto a new home. And here we have 4 matched Toshiba 2879 transistors. The flybacks are not been roasted. The input attenuator has not been roasted. Everything in here looks stock. Looks quite impressive, actually. Let's start over here with the output filtering network. That is this. This is our, correct me if I'm wrong, but I'm pretty sure, hold on a second. Yes, there is no input filtering network on this device at all. I was thinking for a second that this might be the low power input filtering network. It is not. This is your output final low pass filter, and this is your notched filter network that works hand in hand with the output filtering network. So this is your primary keying transistor or relay. So yeah, I mean it's really straightforward. Toshiba. Let's turn the gain down a little bit so we can see the logo on the actual top of the transistors. Original solder work, obviously. Good print, not the Chinese knockoffs, which is an issue. There are no burn parts inside this box at all. The diodes across the transistors with thermal compound to help regulate the bias as you go up and down in heat. Over here, this is your overprotection network board. This is your input cooling fan. Please note, fan is very clean. So that means who's ever trunk this ever sat in or basement it sat in never got used at all for anything. It's dust-free, dirt-free, and clean. This is your output bridges. This little ferrite here, and this little ferrite, and this is our independent adjustments for the bridges. And this is what feeds the cutoff board over here. Over here. I mean, this is just about as basic as you get. I mean, straight up, legit. No variable control on the voltage, straight up do it with a diode reference. It's cool in the bias. Sorry, I'm over here. My brain's over here already. I'm done looking at all of this. These are different trimmers for whatever. You're going to have your high output trimmer trip. Sorry, back over here. You're going to have your high output trimmer trip, then you're going to have your SWR trip, and then you're going to have your over voltage trip. And I can almost bet you money that's what that sum total 3 adjustment pots do. I'm not going to get my fingers in them, but those are the only three things that you got to sense, right? Let's think about this for a second. You're going to put too much drive in it. Okay, so you're going to be looking at your input power. Then you're going to be looking at your output power, and how you would go about measuring that is to make sure each one of the sides is producing power. Remember, this is a 1 2-pill amplifier. It's another 2-pill amplifier. They are combined through here. And where is our input splitter? Oh, they didn't even bother to do an actual splitter over here. They just attenuator. Okay, well that makes sense, because then you're going to have a frequency response that's got to be flat. So yeah, I put like 5 dBs of attenuation on both sides of it. Let's see. 7-ish dBs worth of attenuation on each side of it, and let it self-balance, because then you don't give a crap what the signal actually looks like going into the input transformers at all, because you're buried behind your attenuator. So the only thing the radio is ever going to see as input is going to be attenuation. I really dig these flyback circuits. It's really cool. This is a piece of mag wire, resistor. So you've got your input circuit going through 2 different resistors and going to mags that goes through another piece of ferrite, and then it looks like a 2-to-1 wrapping on this. That works. But then you have your standard flybacks. Huh, that's cool. See, outputs of those wires attach here. That's neat. That's cool. It's pretty straightforward. It's a basic all-band, all-mode amplifier. And I mean, literally, if they can't hear you on 500 watts in a mobile on 80 meters and 40 meters, they ain't gonna hear you. Okay? That conversation that all of us radio operators have in our head. Man, if I just had 100 more watts or 500 more watts, or some of the guys that I run around with, the conversation they have in their brains is, if I just had another 1,000 watts, I would have been able to get over them. I would have got antenna. This only helps you to a point. I say it all day long, every day. Nobody ever wants to listen to me. Your amplifier only helps you to a point. It all comes down to that metal mass above your head. Thermal protection, load fault, i.e. overdrive or high SWR. Set screw just backed off. Okay, so we'll re-index that. So the top switch here is 1.5 megahertz through 2.3 megahertz. The next switch is going to be your 80 meter position, of course, 2.3 through 4, and then 4.4 through 8, 8 point whatever through 14.5, 14 point, wow, that's, you'd actually want to be in that position. So it's 14.5 through 21 megahertz. Boy, I bet I can't wait to see how this works in the testing. It's going to be your aux position, 10 meters, and then remote. Ooh. We've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. The mystery deepens. The mystery, it deepens. Okay. Well, anyhow, to get the remote to work, you put this in the remote position and leave the amplifier in the on position in your trunk. Okay. This is just a very relative amp gauge. There is no ferrite choking from here to the input of the amplifier section, which is, to me, a vulgar abuse of engineering power. Vulgar abuse. There should be some ferrite material that is here. And the 12 volt DC comes directly and gets injected right onto the input transformers. There is no ferrite choking material on the 12 volt DC lines. It's like a mic drop moment. It's like, boom. What? So maybe there was a little bit something to this. This reminds me of these kits they sell on eBay. RFI elimination kit. So, a couple things here that I look at and I see right away that I want to change. Let's look at our power plug. These are our ground leads. 1, 2, go directly to the cabinet. And then, of course, our 12 volt hot. 1, 2. So that means we're expecting all of the current. Where'd you go? Oh, there you went. The knob decided to go flying 10-7. All the current is designed to go through these 2 pins. So why do we need the 150 million amp or $150 million plug then if we're not going to utilize any of these other plugs to help carry current into the amplifier? There's literally nothing else hooked up here. That's 6 pins that we could use to do everything on this box. Why do we need 2 network cables on the front? I don't know. But let's unpack the remote and let's start looking at all those kind of crazy things. These are just, hey, I'm here to document and repair if needed, right? Not to, I mean, in my brain, I could wire 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You guys out there that know what I'm thinking in my head, you know what I'm thinking in my head. Anyhow, this is what it comes, the remote right here, right? Yes, the serial number on this is higher than that number. So I send us this network cable, and this little tiny box. Let's not get all medieval on it. Let's take a minute and open it with a little bit of courtesy and style, since you know that this is going to go live in somebody else's home, BBI. That's 0 through 100. So power, transmit, trip light, power switch. Okay, there's a little bit more going on here than just really 2 network cables. I gotta remember when this was built. I gotta remember when this was initially designed. Sorry, I'm struggling. I'm sorry. The right kind of frickin' dip switch and a bank of resistors, you could easily do all of the band control unit with 2 wires and maybe modulate 1 communication line for the meter. And in that same modulated line with just a little op IC, you could run the transmit receive light. Schematic. So 1, 2, 3. Okay, so they're using 7 positions on the switch, indicated 1 common, which is going to be ground. Then we have 2 isolated leads for the meter, 2 isolated meads for the switch, common case ground. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I watched this really neat documentary the other day, and it was about why we can't make the Saturn V engine anymore. And it has nothing to do with the fact that we don't have the designs. NASA has all the designs. But the way we go about doing things and our ability to manufacture and produce things is way different than what it was when we built the Saturn V motor. And how if we went to go back and they actually paid people to figure this out, they had a team of guys that went back and decided that they wanted to see what it would really take to produce the Saturn V today. And they built it with like 1,400 less parts, cut production time by approximately 2/3, and shaved a whole bunch of weight off of it just because they were able to capitalize on new manufacturing ways of doing things. That and the guys that built the Saturn V, all the little minutiae of being able to get all the little jigsaw puzzle to go together had been lost. That's one of the other major reasons. But it wouldn't be cost prohibitive. But back then, before we'd ever done anything like that, nobody had ever done anything like that. So now we look back at that from 60, 70, 80, 90, 2000, 2010, 2020. Okay. So look at it, 70, 80 years later, our point of view has changed dramatically in how we make things. And I think that's what I got myself caught up doing here, is I'm looking at something that was made in the 90s-ish, the early 2000s-ish. I mean, it would have to be to have these output transistors in them, which are phenomenal. I will take the 40-year-old standalone hardcore technologies transistors and this guaranteed network over the other stuff today. I would, me personally. Although the 188 is an obsolete dinosaur component already within 5 years, and we've moved on to bigger and better things. The 188XR is like a 2290. The 88XR is like the low output power transistor now. The new latest and greatest thing is the 65 volt whack-em schmack-em, almost 2 kilowatts PEP out of one device, if properly cooled chip. But I think my brain's getting caught up in that mode because I just built this amazing remote system for myself and my own vehicle that does probably about 15 more functions than this, and I did it with 5 wires. So I could easily do it with one network cable, is the point. So anywho, let me get all this stuff debagged. We'll get this mounted up and we'll get it running, and we'll see what it does on the old watt meter. And what she does being driven by that. So we shall return, gents. Okay, so moving right along here, I am changing how this plug is wired. We're gonna make the bottom pin, this side pin, and this pin all ground. We're gonna make these top 4 pins all hot. So we're gonna utilize everything but one pin on this plug. And believe me, I've made it representative of the power plug as well. We'll cover this in a minute. But I wanted to show you this. Then I'm moving the ferrite filtering inside. I played with about 6 or 7 different ideas. This is the best way. That kit that was on the outside, we've moved it to the inside. I'm going to add some cover to this, and then we're going to zip tie it down and make it so it can't bounce around and hit anything. I added 2 ground wires. And the reason I had to add these ground wires is because this post was completely broken off. So 100% of the current was going through this one ground pin, which, yeah, it goes down to the case, but it's got to go across the case and then up through the nuts to the board. So don't get me wrong, the metal mass of the cabinet and the metal mass of the heatsink and the vast amount of mounting hardware they've got on the heatsink is more than adequate. But then we just went ahead and added 2 extra wires that are flexible. These are Teflon, so we don't have that problem anymore. And then I mechanically tied these wires into place with the copper that I put in between all the pins. But I wanted to show you the ferrite because pretty soon we're going to cover that up with this. One, to make it look pretty, but two, to keep these from vibrating and making noise or bouncing into anything. So let me get the inside of this finished up, and then we're going to hook it up and we're going to run it. So give me just a second. Okay, so we are on 10 meters. And down here on the front of the amp, we're all the way down in the auxiliary position. Not the remote position, but the auxiliary position, which is 10 meters. We're going to utilize the manual key circuit on this thing, the foot pedal. So let's go ahead and we'll put some drive into it. What is going on here? There we go. Sorry about that. So we're in the auxiliary position. We're on 10 meters. So let's put some drive in it. Hello, 1, 2. Using ICOM 7300. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. About 490 watts. Just about on par. So let's go ahead and we'll flick it over to the 14 through 21 position. So we'll put some 21 megahertz worth of love in it here. We're on 21. Hello, 1, 1, 1, 1. Oh, lost my meters here. Let's see, menu, meters. There we go. Hello, 1, 1, 1, 1, 1. Talk through it, no problem. Hello, 1, 1, 1, 1. About 100 watts of drive. Hello, 1, 1, 1, 1, 1. Hello, 1, 1, 1, 1, 1. No problem. Let's walk over here and let's look at the amp meter. Hello, 1, 1, 1, 1. About 100 amps. Okay, so let's go ahead and go to 20. I don't even have to change anything, I don't believe. So you're going to go to 20. 4, 5. No, I want to go here. Let's go to 20. Hello, 1, 1. Just have my power level different. Nope. I'm on AM, that's why. Sideband. Hello, 1, 1. Okay. Hello, 1, 1. Hello, 1, 1. No problem whatsoever. So let's go ahead and we'll drop on down here to 7. We'll click up one more. So we're on 7. Hello, 1, 1. On AM again. Sideband. Hello, 1, 1. Hello, 1, 1, 1, 1. Hello, 1, 1, 1, 1, 1, 1, 1. Okay. Looking good. Let's go to 80. We'll take it and go to 80 on the front of the amp. Hello, 1, 1. Where is it? Hello, 1, 1. Hello, 1, 1, 1, 1, 1, 1. Hello. So let's go ahead and we'll drop back down over here. Hello, 1, 1, 1, 1. Hello, 1, 1, 1, 1, 1. No problems. All right, now let's go on down to 160. Go there, go there. Let's come back up here. Hello, 1, 1. Hello, 1, 1, 1, 1, 1, 1, 1, 1, 1. So it really likes 160 meters and it really likes 40 meters. That's what we've learned from this little test. Now everything on this amp works just the way it should. Now let's talk about the remote issue. The remote for this amplifier wants to be switched on hot. The remote that I bought wants to be switched on ground, which tells me I got the wrong remote. So this isn't the cheap remote version. This is the older, better, different, whatever. It wants the other remote. So unfortunately, we're going to sell this unit as it stands, not with the remote with it, because I could totally sell you this remote, but it does not interface. Even though the serial number is 100 digits higher than this remote does not interface with this unit. And I sat here and I looked at it and I figured out what was going on with it. And I went, my God, what a pain in the butt. I'd have to change every single wiring pin on the inside of that remote. And I said, nope, I'm just going to return it back to DX Engineering, get my money back, and I'm just going to get rid of this just the way it sits. So we did the power wire upgrade on this thing. We put ferrite chokes on both the positive leads. We supported them internally, put some expanded wire loom on it, heat shrinked everything up, did a good connection here on the back. We went to an international standard Anderson clip instead of this funky connection. They say in the manual that you want to hook this up with a 5-amp fuse. I'm going to send the stock fuse along with it, this one here. This serves as your fault reset for on your remote. Otherwise, if you try to key this thing here, we'll leave it in 160 and try to key it out of band. Watch what happens. Hello, 1 2 1 2. Oh, it's still working. Hello, 1 2 1 2. Hello. Oh, see, now I managed to get it to go into fault. This won't do anything until you turn the amp off and turn the amp back on. Hello, 1 2. Hello, 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. 1 2 1 2 1 2. I think my old foot pedal that's been in about 300 YouTube videos now is finally starting to bite the ghost. I'm going to have to rework that. Needless to say, we're going to ask 14 for this, plus the ride, because it's got the Toshibas in it and not the Chinese aftermarket transistors. This is still a current production run amplifier. They make this to this date, but they don't have Toshibas in them. They got the Chinese transistors that don't hold up as well. So, needless to say, power wire upgrade, real power plug that we're all used to using. That's the appropriate size, 150 amp for 100 amp worth of load. This thing's good to go. So the first one to call me, first one to shoot me a text, first one to hit me up, gets it. I don't care where it's got to go, but it cannot stay here. And somebody's going to buy this up and use this on all the bands because it is a type accepted piece of equipment with the right filtering and circuits in it. Gentlemen, my name is BBI. Thank you. I appreciate every single one of you. Like I said, this is for sale. The first one to give me a call gets it. And I'll see you. Click, click.